Hi, this is Mr. Huber, and in this video we're going to talk about exercise 16. Find the size of the interior angles of a rhombus with diagonals E 57.2 and F 81.7. These are the length of the diagonals. Well, first, what's a rhombus? A rhombus is a very special quadrilateral where all the sides are of equal length. Well, I prefer to draw it like a kite, a very special kite, a kite with equal, where the sides are of equal length. Well, you could imagine a kite like this. That's obviously not a rhombus, okay? But it's still a kite. But a rhombus is a very special kite, so you just use two isosceles triangles that you put together like this, okay? And I prefer to draw it like this. You could have drawn it like this, obviously, but I find that much harder to draw my rhombus like this. So I very much prefer to draw my rhombus in this position. Then, whenever you label something like this, you do A, B, C, D, A, B, C, D, and then this would be the diagonal E, and this would be the diagonal F. According to the alphabet, E is before F. Or you could say A, B, C, D, and then this would be the diagonal E, and this is the diagonal F. So that's what I'm going to do because E seems to be shorter than F. So A, B, C, D. So this here, this diagonal here, is E is equal to 57.2. And this diagonal here is F, and that's 81.7. 81.7. So we need to work out the interior angles, okay? So let's label this angle here alpha. Well, obviously this one is the same. And let's label this angle up here delta. So this would be beta, and this would be gamma. Well, obviously, alpha is equal to gamma, and beta is equal to delta. So if I work out delta, I can work out gamma. If I work out delta, I know what beta is, and if I work out gamma, I know what alpha is. Okay, now look, it's very easy because I could work in this right-angled triangle. Okay, so I could say this is delta halves. So then we know this is half of E and this is half of F. So you could say tangent delta halves is now E halves. Opposite, for this angle, this is the opposite side, over the adjacent, which is F halves. But I don't want to divide these by 2, so I can just use the trick we used in the previous exercise. E halves times 2 over F. So tangent delta halves is nothing but E over F. So delta halves, you use the inverse tangent, is arc tangent E over F. And then delta is 2 times arc tangent E over F. You can obviously plug in the numbers right away, which if you want to. So delta is 2 times arc tangent of E, 57.2, divided by 81.7. So let's type this in. 2 times inverse tangent 57.2 divided by 81.7. Well, we're going to get delta is approximately equal to 69.99 degrees. Now, well, you know that beta is also 69.99 degrees. And you know that the sum of the interior angles in a quadrilateral is 360 degrees. So alpha plus beta plus gamma plus delta is 360 degrees. Well, you know alpha and gamma is the same thing. So these two is 2 times alpha. These two is 2 times delta plus 2 times delta is 360 degrees. So 2 alpha is 360 degrees minus 2 delta. So alpha is 360 degrees minus 2 delta divided by 2. Well, now you can type this in. 360 minus 2 times the answer from before divided by 2. Well, if you typed it in like this, that would be wrong, so you need some brackets here. Like this. And we'll work it out. It's alpha is approximately equal to 110.01 degree. So you can do it like this. You could obviously have worked out alpha half. So you could have obviously have done it like this. Tangent of alpha halves. So you could have said, well, this now is alpha halves. And then it's opposite over adjacent. Well, that's f halves over e halves, which is f halves times 2 over e. So tangent alpha halves would have been f over e. So if you do that, alpha halves is tangent to the minus 1 or inverse tangent or arc tangent of f over e. So alpha is 2 times arc tangent and f is 81.7 over 57.2. So let's type this in. 2 times tangent to the minus 1, 81.7 divided by 57.2. And that would have been the exact same thing. Alpha is approximately equal to 110.01 degrees when rounded to 2 decimals. So either you use this method by using the fact that the interior sum of a quadrilateral is always 360 degrees, or you work it out like this. So I hope it wasn't too difficult. See you on the next one.